Today we're going to review the idea of greatest common factor. The last time you saw this was probably in middle school. So our work today is going to see how do we level that up to an Algebra 1 level. And we're going to start by reviewing this word factor and just remind ourselves of what a factor is. So a factor is defined as any number or expression that could involve variables too. So it doesn't have to be just a number alone. Any number or expression that when it's multiplied by another, either another number or another expression, makes a specific value or expression. Let me spell that correctly there. A specific value or expression. So let's look at just an example. What are the factors of 12? So 12, we could think of 1 times 12, right? So that would mean that 1 and 12 are both factors of 12. Since 2 times 6 makes 12, that would make 2 and 6 factors of 12. Or 3 and 4. So we can think of, right, these are numbers that when multiplied together make 12, and that's why they're called factors of 12. Something like 20x. So now it's not just a number, it's an expression that includes a variable. So how would we come up with 20x? Well, maybe we have 1x times 20, right? That would make 1x or 20 factors. We could have 1 times 20x, right? We could do 2x times 10 or 2 times 10x, right? We could make those pairs depending on where the x is. We could also have 4x times 5 or 4 times 5x. So when we put a variable in that expression, it's important that the variable shows up in our list of factors as well, because without the variable in the factors, we wouldn't have the variable in the final expression. So this brings us to the idea of a greatest common factor. So the greatest common factor is defined as the largest factor that two numbers or expressions share. So the largest factor that two numbers or expressions have in common, right? That's why we call it a common factor. So if both numbers or expressions have the same largest factor, we call it the greatest common factor. So let's do an example. What's the greatest common factor of 20 and 50? So how you might have done this, back in the sweet middle school days or even elementary school days is think about, well, what are the factors of 20 and what are the factors of 50? Okay, so I list them out. The factors of 20 are 1, 2, 4, 5, 10, and 20. Those are all the numbers that when we multiply, one by the other, we would get 20. 50, we could do 1 and 50 in there, 2 and 25, and then how about 5 and 10? So we've got another 6 factors there. So clearly 20 and 50 have some factors in common, right? They both have 1 in common, they both have 2 in common, they both have 5 in common, but the largest factor that they have in common is a 10, which means that our 10, our greatest common factor between 20 and 50 is 10. So we're going to do just a few more examples like this, and really we're focusing on what is the greatest common factor. And yes, this does seem a little bit elementary, this does seem a little bit basic, but like I said, we're talking today about how do we start to level it up to an Algebra 1 type skill. So 48 and 12. Well, if I think about the relationship between these two numbers, 12 actually goes into 48, right? 4 times 12 is equal to 48. That means that our GCF is actually equal to 12. And so a little pro tip there is that if one of the values is a factor of the other, then that value is the GCF. So in this case, 12 goes into 48, so 12 must be the greatest common factor between them. How about something like 7 and 22? Well, let's think about what they have in common. 7, we could come up with 1 times 7, and that's about it. 22 isn't much fancier, right? 1 and 22, or 2 and 11. So the only factor that they have in common is 1. Now it seems like 1 isn't a very large number, right? How can it possibly be the greatest common factor? But if two numbers have no other factors in common, the GCF is always 1. So I'm just going to make a note of that. If two numbers have no other factors in common, whoops, in common, the GCF is 1. Sometimes we call these numbers co-prime, meaning that they don't share any factors other than 1 together, but that vocabulary word is just a little higher level. So example 6, now we're looking at two expressions that involve variables. So our last few examples were just pairs of numbers. These ones are pairs of expressions. So when we look at 25x and 15x, well, we could think first about the numerical coefficients. So I could first think about what's the GCF of 25 and 15. So 25 and 15 have 5 in common. That is their greatest common factor. And since both of these terms have an x, whoops, then our GCF here is actually 5. So just as a reminder about that variable, right? We said earlier that if a variable is a part of the expression, it can appear in the factors. So if both expressions share a variable, then it should appear in the GCF. So one more example here. This one, again, we're just getting a little bit more complex here. So this is the GCF of 24x and 6x squared. So again, we can think about the numerical coefficients, so 24 and 6. We know that 6 goes into 24, so 6 is probably going to be a part of the GCF, but I want to explore just a little bit more kind of what these numbers entail. So 24x, we can think of it as 6 times 4 times x, right? 6 times 4 makes 24, times x makes it 24x. 6x squared, we could have 6 times, and then an x squared is really just an x times an x, right? And so what these have in common is they both share a 6, and they both share an x, right? So therefore, our GCF is 6x. Again, it's the largest that they have in common. Now, one of them was an x squared, right? 6x squared, but that x squared is not a part of our GCF because the other term, the other expression, didn't have a square in it. So just another little piece of advice, if the terms or the expressions share a variable, this time with different exponents, then we're going to use the smallest exponent in the GCF. So between x and x squared, our smallest exponent was a 1, right? X to the first power, and that's the one that we used in the GCF. So I would like you to try these next few on your own, and we'll check back and see how you did. So between 30x and 75x, their GCF should be 15x. 15 goes into both 30 and 75, and both expressions have an x in common. 66xy and 30xy squared. Well, 6 goes into both of those, 66 and 30, so our GCF will be 6. And if I think about x, y, right, in that 66 is x times y, and then x squared y from the 30x squared y is x times y. What they have in common is they have an x in common and they have a y in common. And if it's a greatest common factor, that's all I care about. So I get to cash out an x and a y as a part of my GCF. Last one here, 140m squared, 140m, and 80m to the fourth. So again, I'm going to think about my coefficients there, right? So I know that my greatest common factor is going to involve the largest number that can go into 140 and 80, which as it turns out is 20. And then I'm dealing with m squared, m, and m to the fourth. And so by my rule, the smallest exponent with those variables, my GCF should include just m to be 20m. And again, if we want to verify why that is, we can think about, well, what is m squared, what is m, and what is m to the fourth compare, and what do they have in common? M squared is m times m is m to the fourth is m times itself 4 times. And what these terms have in common is only a single m. And that's what goes in our GCF. So I encourage you to go to your practice assignment and do maybe the first part, right? It's broken up into 2 parts. Go through and do the first part and check your answers before going on to the next video when we start to look at how we're actually going to use this. So take care and let me know if you have any questions.